Here we are, talking about talking, but also researching water fuel process in a place in Australia, which we will remain nameless just for now. And this is a car, and this is the engine, of course. Well, what we've got here today is what we saw the other day, a water fuel cell. As you can see, zooming in. I don't know if you get a good picture on that. There's mesh in there, core, three meshes in there, a center electrode, negative or positive, doesn't matter, and then a floating unit that's not connected, it's insulated from everything else, and then an outer mesh filled with water, a teaspoon of caustic in about 4 litres, so this is about a quarter teaspoon to 2 litres. Here we'll see the gauge. There's a vacuum gauge. The maximum, the vacuum runs in that direction as it increases. The tube here runs flexibly all the way in and under the carbby where the normal breather off the manifold comes in. I'll just get a shot of that around here, coming in underneath there. If you can see that without backlight. Anyway, so what we're going to do is kick the engine over, then we'll do a reading off the vacuum, then we're going to read off this voltmeter. It comes on about 13 volts and then decays. Now this unit will work as long as the vacuum is connected and produce gas without being electrically connected. Now we're going to electrically connect it. And you see a lot more gas. 13 volts approximately. So now we'll connect the voltmeter up. Can you come and hold the voltmeter on, please, Peter?
Fingers up there.
The fingers up, Peter. Peter fingers. Now, focus on the voltmeter. 8, 7, 5, 7, 4, 13.7.
Right.
Now disconnecting, and it's dropping down to, what's that, 1.3? That was quick. Now you've got 1.2 volts. There's still bubbles being formed in the chamber there, in the cell. 1.14 volts, still gas coming out. There's no connection on the battery there. Down to 1.01 volts. Okay. We're stabilizing about 170 milliamps. About 10 minutes later, after we charged it, it dropped down to below 1 volt now, to 700. Should drop down to 170. We'll check it again in a minute or two. Okay. The voltmeter's reading 700 millivolts now.
At this stage, this unit's charged. It will apparently pick up the vapor very, very quickly. Because we've charged it, it's now HOH, hydrogen, oxygen and hydrogen. Easily separate. I'll just touch it so that you can see it coming away from the actual unit. See how that's producing there? And now just touch the ignition. That's still connected. I'll now disconnect. You can watch the unit. Produces exactly what you require at the time. The worst part about this is that you're now getting more water out of the exhaust, which you could in fact recirculate and make the unit operate fully.
yourself up with that thing.
What do you actually wire it up to then? Nothing.
Plastic lever. It's
No,
going to the
mine.
just
That's right up to itself because it's charged. Yeah, it becomes a battery after a while.
3 minutes or 3 miles to
Yeah,
become
well,
a
we
battery.
had to do up about 5 minutes before. Yeah. No, now it's
So that's producing its own gas. You
Oh,
see the
right.
gas?
Yeah.
Right? And when you hook it up to the original battery, then your water fills full of...
See how that vapour immediately comes off?
That's what was done in my units before. You will get heaps more vapour when you have a stainless steel outside.
Yeah.
Understand?
But just for the practical purposes of being able to see it.
Yeah. Yeah, that's good. That gives you
So
that
that's now
idea.
with it, now connected.
To the gas and light.
Oh, no, that's no good.
So actually that verifies my idea on the polythene expendable unit. Because you can see that it's only using still the gas what it is pulling off under its own, see? And it's not using any of its own.
Yeah.
See that? That means that when you have a flexible unit, the gas you produce with current expands the unit.
If you didn't have it attached to your battery, just use
When
that.
she's charged,
Yeah, fully charged. That
She'll
should
start
still, that should still run without the exchange.
yeah,
So has anyone got a pressure gauge?
means that you haven't got your vacuum lift on the water.
Right.
Is that right?
Yeah, right, yeah.
When you've got a solid container, you can lift that amount of water clean out through the top.
Yeah.
Because you take off your vacuum. There you've got pressure because the lid is
Right.
pressurising.
Right.
Does that make sense?
Yeah.
Good. Because you can just take all that pressure
Oh,
off.
the amount of flex is...
Straight in under the unit. Where your Venturi lead, the top of your motor goes directly under your throttle, under your carby.
These are lead up.
We're putting the gas directly in where the exhaust gas, or the bypass flow gas that comes from the top of the motor, goes directly under your throttle. It's under the carburettor, so that you've got maximum vacuum direct into the motor.
Okay.
With the vacuum gas and everything else, you have to have gas to motor usage, air and gas, intake of air and gas, to the exact fine critical point. It's a hair whisker line. The same as the distributor. When you cut off your petrol and go to your gas, on petrol you can turn your distributor like that and it hardly does anything to your motor. When you put the gas on, you move it
Minimally.
not even the width of a piece of foam and paper. And your motor will shake like anything or shake like anything either way. And you have to hit that exact point or else you won't get your efficiency, you won't get your motor to run.
Just changing the distributor.
Your distributor has to come, when you cut off your petrol, if you run petrol by itself, you're set at your normal, whatever it is, 8 degrees or whatever. If you hook up the petrol and gas, you would then, instead of 8, you would come up to say about 15, 12 to 15. When you cut out petrol altogether, you would come from 15 up to somewhere in about 25 to 30, maybe more, depends on the vehicle. Whatever vehicle is all different by that. But you have to come straight around to that. You can start it at your 30 degrees advance with your gas, off your ignition, and she will start like that. First go. If you go back to 1 drop of petrol with the gas, she will go rup, rup, like the timing is too far advanced, like normal. Right? So if you go back to your petrol, she's too far advanced. If you're on the gas, she'll pearl over like she's just starting on normal petrol. So it's that critical of alignment. And when you mix with your vacuum and everything, you have to get your right gas to your right air with the hydrogen oxygen vacuum.
Right
sucking.
ratio.
And if you don't get that, it's that critical that she won't go either. So, we're all in the experimental stage, right?
Yeah.
I'm not going into it, but I have had a Rover 3500 V8 with twin carbies, a Zenith same as SU Carvey's running. And that was with a solid unit. I didn't understand why the vehicle seemed to start and run perfectly when nobody else seems to be able to hit it. It was a Leyland P76 V8. Now the whole motor on it is open. It has an open dipstick, it has an open oil cap, it has an open motor. It has a petrol pump on the bottom which has two little breather holes in it, and they are open, which air goes to the sub. Now I have never had it running on a solid stainless hydrogen unit, because two things happen. I've had it running on a polythene unit with plates in it, which you have on tape, and that unit expanded. When you powered on, it expanded. There was a pressure there. When I first hooked up to the motor polluted 10 times worse than on petrol. 10 times worse. And it had a pressure. It was pressurising the sump out. But it was dangerous. Hooking up to a polythene unit or an expandable unit or a contracting one of any sort, whether it's stainless and it can expand under acceleration or anything, it's dangerous. It'll blow up. So the Rover V8, the Leyland V8, sorry, it ran. I went from Casino to Lismore and back again, polluting in the motor itself all the way. But I don't know why it didn't blow itself up, because that unit was expanding under acceleration. The unit just expanded out, and if that gas can get out anywhere, you're gone. The car, everything around's gone. With a solid unit, it does the opposite. The solid unit has a vacuum to the sump, gives you tremendous power, gives you tremendous backing off, and gives you smooth running, economy, and no danger.
No pollution.
No pollution in the motor or out the exhaust at all. None. We've had readings on that. We've put it over an analyzer, and it don't read. You put a polythene unit on, and you get the opposite effect. You get a pressure in your sump, which then blows fumes and smoke and soot and shit out. But it also pressurises the unit. It also makes everything wrong. Wrong way to go. So they're the two things I've had. I've made a few units. I've made polythene ones, I've made stainless steel ones, I've made stainless steel ones what can expand under vacuum. And they're very, very, very dangerous. Polythene ones don't seem to be as dangerous, but no one in the world's going to get me to run one again. So the idea would be to have a stainless steel cylinder and put some neutral plates in. You know what I mean?
Neutral tubes, yeah. We've explained that on the video before.
Yeah, it's already explained, so that's what you know what to look at when I say that. That then will give you what you need. Because if you don't do that, and you have big units like what you have here now and so on, you're going to use a lot of amperage. You're going to flatten batteries. It's not going to do what you want. You're going to end up in trouble that way. I've already had those big ones running, and 10 minutes you flatten the battery and drain an alternator. Every bit of alternator.
That's if you don't have the neutral plates in it, or if you do?
That's if you don't.
But if you do...
It becomes smaller units like you've already...
But what about on the big units? Can we put floaters in there and bring it down to 5 or 7 amps or something?
In big units, you can... I don't care how big you make them. You can put...
As long as you've got floaters in there, you bring the amperage down.
You bring the amperage down.
So we can probably get...
The current seems to go from a positive and a negative, and instead of staying at that, whatever it's going to use or pull or whatever, it then seems to break them down and bring them back the opposite way, but produces twice the gas. You've already seen that on video, it shows. You put a neutral one in there, you use a lot of amperage. I mean, you put positive and negative, just single plates. You use a lot of amperage, and you don't seem to get off the gas you want. So the idea will be, if you are trying to run a vehicle and use a positive and a negative in it, just singly, you're going to have to go bigger units. But to do that, you're going the wrong way, because then you need heaps of flaming amperage, you need bigger batteries, you need more current to run it. So that isn't the way to go.
Right.